Okay, so now that you've seen the vocab for 12-2, let's go ahead and talk about how to make these things. First off, making your own frequency table. It's the easiest part of it. You just have to be able to count. So you've got the numbers of home runs hit by batters in a local home run derby are listed below. What is the frequency table that represents the data? Now here's the thing. You get to decide, right, what the intervals are. But don't make them something ridiculous like 2 to 20, right? That'd be kind of pointless in this case. Or 1 to 10 and then 10 to 20, whatever. It doesn't give you much information. So now here's the thing, though. The difference is if you make a whole bunch of intervals, it might be too much information, right? It might not be useful in that respect. But if you see, a certain number of them, again, depending on what the data looks like, it can tell you, hey, do they kind of cluster in a certain number? Things like that. So the minimum data value is 2, and the maximum is 17. So you can divide it up evenly into, I'd say usually 4 is the least number, depending on the kind of data you're dealing with. In the first column of the table, list the intervals. You count them up, and then you list the frequency in the right column. Pretty straightforward stuff. So what is the frequency table for the data? And problem 1 uses 5 intervals, or intervals of 5 rather, I'm sorry. So instead of 2, 3, 4, 5, which is 4, right? 6, 7, 8, 9. Notice how I count here. These are intervals of 4. 2, 3, 4, 5. And then 6, 7, 8, 9. 10, 11, 12, 13. 14, 15, 16, 17. Now likewise, instead, and I've got the answer down below for you here, I'll bring it up here. If you decided to go with intervals of 5, and again, count with me here. This is important. 2, 3, 4, 5, 6. Some people with 2 to 5, oh, that's 2 to 7. Or if I did intervals of 5, that's 2 to 7. No, you need to count the numbers themselves. 7, 8, 9, 10, 11. 12, 13, 14, 15, 16. 17, 18, 19, 20, 21. Now when you do this, you can see there's not in the upper end in this case, whereas here that kind of data kind of hid there. Everything else is kind of evenly distributed, which is more or less what it kind of looks like here. So, alrighty. So now you've made a frequency table. Time to turn it into a histogram. So the data below are the numbers of hours per week in a group's students spent watching television. What is a histogram that represents the data? So first thing you got to do, again, decide your intervals. You get to decide that. Remember to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? These are intervals of 6, not 5, as you might want to think. Then we list the frequency on the side. And here you would say, you might list how often, right? Frequency is a good word. The intervals go on the bottom. That's the number of hours. And then you make your bars touching as you draw it. Now, there's websites that'll make these for you, that sort of thing. But again, I do expect that you'll make them by hand. I'll give you a ruler or graph paper if that's what you need. So it says the finishing time in seconds for a race are shown below. What is a histogram that represents the data? Now, I don't know what it looks like, the one that you made, right? You could have done larger or smaller intervals, fewer intervals, more intervals maybe. This is one possibility. So notice here, frequency on the side. Whoops, let me switch here. Frequency on the side, intervals on the bottom, label, 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 and bars touching all of the same width. That's important. So those are the rules. Again, this is one possibility. Yours might look different. Now that we can make a histogram, it's time to talk about reading them, getting data from them. So is each histogram uniform, symmetric, or skewed? That's more important to figure out first, right? So this one, we can see, is uniform in its shape. I'm sorry, symmetric, not uniform. Sorry about that. Symmetric. I could draw a line in the middle. It would look kind of mirror-like. Not exactly. These two are at the exact same height, but kind of. This one is skewed, and again, we call this skewed left, right? Whichever side's higher, you pick the opposite side, and that's skewed that direction. But whatever this one's telling us, it's telling us a lot more happens at this end of the deal, right? Alrighty. So it says the following set of data, right, shows the number of dollars J spent on lunch over the last 2 weeks. Make a histogram of the data. Is the histogram uniform, symmetric, or skewed? And now the thing is, it might depend on what intervals you decide to break it up into to determine how it really does look. So if we take a look at this one right here, we took that and it's been divided into 1, 2, 3, 4 intervals. Here's the frequency. And 1 to 5, 6 to 10. You guys can read it there. Amount of money spent, how often. And this one, it's more or less uniform because you've got very few at this far end here, so it's more or less uniform. Some folks might have been tempted to call it skewed right, but usually when it's skewed, again, you'll see some more growth on the other end there. So, B, how much money should Jay plan to bring for lunch next week? Explain your reasoning. Well, so one idea might shoot for around $70, right? Because again, for the week, we're talking 5 days here, right? The data is fairly uniform, so the average he spends is about $10 a day. So there you go. Maybe a little bit more than that, account for dessert someday or something. Okay, so the idea of a cumulative frequency table. It basically adds on one more column. So we've obviously got our intervals. We've got our frequency. And cumulative means you add as you go. So there's 11 in this interval, right? So it's 11 is the cum. Well, there's 3 more in this interval. So 11 plus 3 is 14. There's 3 more in this interval. 14 plus 13 is 17. So it keeps a running cumulative total for you as you go. So that's a cumulative frequency table. Similar story here. You're given a set of data again. You decide the intervals, so yours might look a little bit different. But again, intervals here of 5, right? And keeping track of your frequency and adding it up as you go. So 6 in this interval. Well, 6 plus 4 is 10, so the cumulative grows each time. What this does is it gives you a total at the end is the idea, or how many between, or including all these intervals as you go. Again, just called cumulative, like adding up as you go.